Good morning, children. Today we are continuing chapter 10 circles, theorem 10.3. The perpendicular from the center of a circle to a chord bisects the chord. The perpendicular from the center of the circle, that part is given, and to a chord bisects the chord. Bisects the chord we have to prove. Let us see the diagram. What is given in the question? O is the center of the circle, OP perpendicular to the chord AB. See the diagram. AB is the chord, okay. OP perpendicular to AB, this is given. Now what we have to prove? This bisects the chord. Bisects the chord means AP equal to BP we should get. So we'll write given a circle with the center O and OP perpendicular to AB. To prove AP equal to BP. For this, construction is required. What is the construction? Join OA and OB. Join OA and OB. Now after joining the OA and OB, you can see that we are getting two triangles, OAP and OBP. So proof now. In triangle OAP and triangle OBP, angle P is equal to angle P equal to 90 degree given. OA equal to OB. What is the reason? Radii. OP equal to OP common. See, OA is the radius, we can mark a equal sign here, and OP common side and 90 degree. So if it is 90 degree, this side is also 90 degree, that is given. So this is the hypotenuse and 90 degree and the common side. So what we will get a RHS criteria. Triangle OAP is congruent to triangle OBP. RHS. So what about AP and BP? Both are equal. By which rule? CPCT. So this is one of the important theorem. You will get the application in 10th class also, this theorems. So learn thoroughly. What is given in the question? The perpendicular from the center bisects the chord. So what is the meaning of that one? If AB length equal to 8 centimeter, if AB length is equal to 8 centimeter, then OP perpendicular to AB means the length of AP equal to 4. Right? Suppose AB length equal to 10. By this theorem, what is the meaning of AP? AP equal to 5. Now you got the idea. Once again, I'll say the proof. That is OP perpendicular to AB is given. Now construction part, we have joined both the radius OA and OB. Now we are getting two triangles. In that, angle P equal to angle P 90 degree, one common side, and OA equal to OB. By RHS criteria, triangle OAP congruent to triangle OBP, and from this AP equal to BP. So what is this one? It is bisects. The chord is bisected. So hence proved. Theorem 10.4. The line drawn through the center of the circle to bisect the chord is perpendicular to the chord. This theorem is the converse of previous theorem. The line drawn through the center of the circle, that means OM is a line drawn from the center of the circle to bisect the chord. This time chord is bisected, that is AM and BM are equal. If that is the case, angle M is equal to 90 degree, right? Angle M is equal to 90 degree we have to prove, right? Again we have to join the same steps only. So given a circle with the center O and OM bisects AB is given, that is AM equal to BM To prove OM perpendicular to AB. Construction. This time also same construction only. Join OA and OB. So after joining the OA and OB, you can see that we are getting two triangles, OAM, first triangle, and the second triangle is OBM. So OA equal to OB radii, AM equal to BM given. Now what is left? No angle is given this time, so OM, the third side we can go OM equal to OM common. Triangle OAM is congruent to triangle OBM. This time which criteria? SSS. OA, the side you can see. Then the third side is common. Already AM and BM is given in the questions. All the three sides are used here. So SSS criteria, all these two triangles are congruent. Now what you can say about angle AMO? AMO equal to angle BMO equal to CPCT. Equation number 1. Now angle AMO plus angle BMO equal to 180. If I am writing it, whether it is right or wrong, it is right. What is the reason? Linear pair. Already the same proof we have written for many theorems. Now AMO and BMO are equal, so we will write AMO plus again angle AMO. We are replacing angle BMO by AMO equal to 180 degree using 1. So 2 times of angle AMO equal to 180, or we can say that AMO equal to 90. So what is the meaning of this one? Angle M equal to 90 or OM perpendicular to AB, hence proved. So what is the proof here? OA, OB we have joined, we are getting the two triangles, and in these two triangles we are using which criteria? SSS criteria. The first side is AM and BM because it is bisects the chord already given. OM is the common side. Now radii is the third side. All these three sides are we have used, so these two triangles are congruent by SSS. Now what is the CPCT? We are writing these two angles because here we have to prove 90 degrees. So angle AMO equal to BMO by CPCT. Now sum of these two angles is 180 degree. What is the reason? Linear pair, and both are equal to each other, so each angle is equal to 90 degree. That means OM perpendicular to AB. So when we these two theorems are having higher class application, including this 9th class also, we are getting many sums based on this question. Simple only, but you learn the proof correctly. Theorem 10.5. There is one and only one circle passing through three given non-collinear points. So what is given there? Three non-collinear points are given, and what is to be proved? There is one and only one circle which passes through the points. Let us see the questions now. See, 3 points are given. That is also non-collinear, they told. That means it should not be on straight line, in single straight line. So A, B, C we have taken. The same concept when you learned even a triangle. In case of triangle, 3 non-collinear points are required. So the word is familiar with you. It's not a new word. So we have taken 3 points A, B, C. Now what is the first step for this one? Means we have to join these 3 points. So AB we should join, and as well as BC we should join. So we have joined these 3 points, AB first line segment and the BC second line segment. This is the first step 1 for this question. Join AB and BC, that we have already done. You have seen the step. Now what is the next step? Draw the perpendicular bisectors of AB and BC which intersect at O. Join OA. So what we have to do here? Perpendicular bisector of AB and BC. And if you draw the two perpendicular bisectors, we can see that it is meeting at one point. We are marking that one point as O. Now AB and BC last step we have joined. Now what is the more than half radius we have to take, and I have drawn here that arc. You can visible already there. First arc and this side below the line. Similarly for this side BC also I have drawn, and I just make it in dark for you. So it's a lower class portion, perpendicular bisectors more than half. So when you join, it is intersecting at one point, which is that point O. Now what is the next step? I told after getting O, we should join OA is written. It is not necessary that we should join OA only. We can join OB or OC also. Or everything is correct, but only one is required now. So we have joined OA. So what is the step now? What we have done now? We have drawn the perpendicular bisectors of the line segment AB and the line segment BC. Both perpendicular bisectors will meet at one point, that is we marked as a O. After marking as O, we have joined the OA. With O as a center, OA as radius, draw a circle which passes through the given three non-collinear points A, B and C. Let us see how it is. What we have to do? O as a center, OA as a radius. We have already joined OA, right? That should be radius for us. Now draw a circle which passes through the three given non-collinear points A, B, C. Let us see the step now, how the diagram will come. The last step how it is means we have to keep O and A as a radius, OA as the radius. Now if you complete the circle, it will passes through C as well as B also. Now you completed, I have darkened already. What we should do after getting O, OA as a radius we should take, right? OA as a radius. Just pass through C and B first, then complete the circle. So how many circle we got? We got only one circle. How many points are given? 3 non-collinear points. Now how to justify is the questions. So here I'll do the justifications. Before that, what are the first step? A, B, B, C we have joined 3 non-collinear points. What was the second step? Draw the perpendicular bisectors of AB and also BC which meet at O. After getting O, one point, either A or B or C. We have chosen A, OA as the radius. We have to draw a circle. Definitely it will pass us through A, B and C also. Now let us see the justification. How to justify this means we have to join OA, OB, OC. We have joined only for constructing the circle only one radius. Now the remaining radius, which is that one OB also we have to join, OC also we have to join. So let us see that step. So now we have joined. How I can write OA and OB are equal? Because we have already learned the perpendicular bisector property. When we are taking any point on the perpendicular bisector of any line segment, it is equidistant from the end points. For example, AB is the line segment we have taken and we have drawn the perpendicular bisectors like this, more than half. So if we take any point on this theorem already proved in I think lines and angles only, that is equidistant from P, AP equal to BP. If I taking Q, so AQ is also equal to B, right? So this is the one of the property of perpendicular bisectors. So perpendicular bisector only we have used here, right? So that is why we are telling that any point on the perpendicular line segment is equidistant from n points of the line segment. I clearly mentioned the reason justification. So you got the idea now. So now BC also we have drawn the perpendicular bisectors. So that means OB is also equal to OC. O is lies on the perpendicular bisector of BC. O is lies on the perpendicular bisector of AB we told first. Now we are telling that O is lies on the perpendicular bisector of BC. So first step OA equal to OB. The same reason only for OB equal to OC. Now see the justification. So OA equal to OB, OB equal to OC, two equations we got. What is the reason? I have written the reason here. See that every point on the perpendicular bisector of a line segment is equidistant from n points of the line segment. So now what you can say this one, OA equal to OB, OB equal to OC. So all three are equal. Let us take R, that means radius. Now clearly what we have to do, if we draw a circle with O as a center and a radius R which is equal to OA, which is equal to OB, which is equal to OC also, it will pass us through A, B and C. So this proves that there is one and only one circle passing through the given three non-collinear points A, B and C. So this is the justification. It is easy only. Now lastly what I want to say that the theorem proof is not necessary to learn for this academic year because of the situation. They have deleted the proof, but this application is coming in the exercise. So you must know that it is a perpendicular bisector applications, and so we need this one. There is no need of learning this one, but you know the construction and all for how we are calculating the center. What is the theorem? There is one and only one circle passing through the three given non-collinear points. So the steps are: join AB and BC, draw the perpendicular bisectors of both, it meet at O. Now join with O as center, OA as a radius, draw the circle passing through the three given non-collinear points A, B and C. Now see this diagram. ABC is a triangle because three non-collinear points means we can form the triangle only. So ABC, if you join, it's a triangle, and the circle you can see it's a covering outside the triangle only, boundary means this circle is called a circumcircle. There is, what is we learned here, there is a unique circle passing through the three non-collinear points ABC. This circle is called a circumcircle. Therefore correspondingly the radius, that is OA, OB, OC are called circumradius, and the center O is called a circumcenter. What is the name of the circle? Circumcircle. And the center is called a circumcenter. Radius is called a circumradius. So circumcircle, when we are doing, what is the concept behind that? We have to draw the perpendicular bisectors. So this is the theorem. This is also you have to learn because the construction will come in later part. That time we should get the idea that perpendicular bisectors, with the help of the perpendicular bisectors only, we are drawing the circumcircle. Given an arc of a circle, complete the circle is the question. So arc of the circle. Given an arc of the circle means part of the circle, and the question is asked for complete the circle. So arc of the circle means from here to here it is given. On that part we have to take 3 points, just we have done in the theorem, last theorem. So then AB and BC we have to join. After that what is the next step? Draw the perpendicular bisectors. Again it will meet O. So with once O is got, what is the next step? With O as a center, right? O as a center, OA as a radius, we should complete the circle. Repeating the same step what we have learned in the theorem only, AB and BC. So join and draw the perpendicular O. First it was given this much only, A to C, that is arc of the circle. Now you can see that we have completed the circle. Let us see the steps once again. Take 3 points A, B, C on the circle, join AB and BC, draw the perpendicular bisectors which meet at O. Once you got the center, we can complete the circle. That only we have done. The same steps only, the last theorem. So I think after doing the second part, that is given arc of the circle, you learned how to do the constructions. So with this, today's video I am winding up. Thank you.